So I'll, in the next 15-20 minutes, I'll bring you from Malawi to the Middle East. I'll talk about the impact of climate on refugees in the Middle East, and then I'll talk about what the Arava Institute is doing to deal with this challenge. I think you're all familiar with this graph from the United Nations Environmental Program that shows that the Eastern Mediterranean and the Middle East is a hotspot when it comes to climate change. The temperature increase here is much higher than the global average. The acidity of the Eastern Mediterranean is much higher. The pH is much lower. We see not only migration of people, but we see a lot of also of invasive species inland and also in the sea. See a lot of marine biology that migrate from the Red Sea into the Eastern Mediterranean. See a lot of the minor bird plantations that we see them on the ground and also in the sea. And probably last week or before 10 days, we all read what happened to the what's the word in English? The Kibodiam in Eilat, the porcupine. It's not the porcupine. It's in the Red Sea. All of them that what's the word in English? Sea. Okay, that's it. Okay, so what is the impact of the droughts, the extreme weather conditions in the Middle East on the climate migration? According to the United Nations High Commissioner for Refugees, the estimate is that there is more than 20 million people have to migrate in the world because of the extreme weather conditions. And in 2021 alone, there were more than 3 million people, just the Middle East and North Africa, had to migrate because of the extreme weather conditions. And when we also look to what's happening in the Gulf countries, in the Gulf states, there is a World Bank report that was published in 2017 that shows within like the next 40 years, these countries, because of the droughts, the aquifer salinity, these countries have to invest more than 15% of their GDP to fight the climate issues. And if we get closer to Egypt, to the delta of the Nile, which is the home for more than 20 million Egyptians, and it contributes almost like to 13% of Egypt's GDP. The salt water intrusion into the aquifer, the increase in temperature, which causes actually diseases and significant challenges to the agricultural sector in the delta. The expectation is that 50% of these people will have to migrate in order to find other jobs. So what will happen to these people? They will either migrate to Europe or to this part of the region. And if we get closer to the Palestinian Authority, the median age in the West Bank and Gaza, can you give a guess? The median age, if you look to the window and look to Isaiah or to the other side to Anata, 20. Yeah, 19, 20. That's the median age. Okay, and in a very close region to Israel, 57% of the population in the West Bank and Gaza are below 24. Okay, and 92% are below 50, 55. Oslo Accords happened in 1993, and the last elections in the Palestinian Authority took place in 2006. Okay, yeah. That means 50% of the people who have the right to vote, they never voted in the West Bank. Unemployment is very high, and we're talking about a very young population. And if we do a comparison, if you look to the statistics that are published by the Palestinians themselves, we see that in agricultural areas, the population growth is much lower compared to other regions in the West Bank. And the same thing also for Gaza. The migration from Gaza, it's a phenomenon that no one talks about. Some statistics say that every year, like 10,000 people migrate out of Gaza through Egypt to Europe or to North America. So this actually causes instability. It's not only an environmental issue, it's also a first-degree security issue. Unstable neighbor, that means unstable home. And this is what we try to do at the Arava Institute. What is lacking in the Middle East? We have plenty of these treaties, nice photos, okay, but there's no peace on the street between the people. We have plenty of renewable energy resources. The Arava region receives one of the highest solar radiations in the world. So we have the technology, we have the natural resources that we can produce the electricity we need to desalinate the water, to use the water for drinking and also for agriculture. So the region doesn't lack peace treaties, doesn't lack natural resources or technology. What lacks in the region is trust between people. This connection is the major challenge of the Middle East. And this is what we try to do at the Arava Institute, to build understanding and then to build trust through the academic program. 1/3 of our students are Arabic speakers, Israeli Arabs, Palestinians, West Bank, Gaza, Jordan, Morocco, Sudan, 1/3 Jewish Israelis and 1/3 internationals. And through academic program, we build trust. And you can imagine when you put in one classroom a Gazan student or Palestinian from a Fiji camp with an Israeli student that finished his army and something happened in Tel Aviv or Jerusalem or in Gaza. And this is what we try to do, to build understanding, to give this young generation the opportunity to see the human in the other. They usually disagree with each other, but they understand each other. And this is what we need in this part of the world. In order to do regional cooperation on environmental issues, you have to build the trust. Why is that? Because most of the natural resources here in this region are shared. Most of the aquifer is shared. The mountain aquifer is shared between Israel, the West Bank, the Jordan Valley, West Bank, Israel, Jordan, the Arava Valley, Jordan, Israel, the coastal aquifer, Gaza, and Israel. So it doesn't matter where the pollution starts or what the challenge is, you have to work with your neighbors. Without working and solving the environmental challenge in Gaza, you cannot clean the beaches in Ashkelon. We also do regional cooperation through research centers. We have several research centers on renewable energy, on transboundary water management, sustainable agriculture, and the Center for Earth Social Ecology. And most of the research that we do in these research centers has a transboundary aspect. Basic research, applied research, research and development, and we do a lot of work with the communities because our agenda is to build understanding and to build the trust. We do this with researchers in Jordan, in Gaza, in the West Bank, in Morocco. And later we established the Regional Climate Change Policy and Research Center. And the photo that you see here is from Kibbutz Ktura. This is the campus and the expansion of the campus at the Arava Institute. We are located at the southern tip of Israel, 30 miles, like 50 kilometers from the Gulf of Eilat and Aqaba. And probably this is one of the reasons that we managed to build and bring people, because it's in the middle of nowhere. So students, researchers fight, but they have nowhere to go. So they go to the same dining room in the kibbutz, the same classroom, and at the end of the day, they share rooms. And the closest city is Eilat. Okay, here I'll give you some examples of the work that we do. This project is with our Palestinian partners. We work with non-governmental organizations. That's why we manage actually to do work. Even the research, the scientific research that we do it through non-governmental organizations with the Palestinian professors, Palestinian universities, but not with the university. An NGO hires a professor from one of the universities, and we do the research with them. This is a project that we managed to send into Gaza 7 atmospheric water generators. It's a machine that produces drinking water from air. It's an Israeli technology. It's not the product of the Arava Institute, but our role was to facilitate between the Israeli army and our partners in Gaza to take these technologies from Petah Tikva in Israel and send them into Gaza. Why do we do that? Because almost 97% of the aquifer in Gaza is polluted and it's not good for the human consumption. Lack of electricity prevents Gazans from desalinating water. Access to the deep aquifer, they don't have enough electricity to pump the water. Gaza receives electricity. Now they are in a good situation, 8 hours a day. Okay, last year, 2 years ago, it was like only 3 hours a day, and that prevents them from desalinating the water. We managed to send into Gaza these systems, 7 systems, totally off the grid, solar energy. The electricity is produced by the sun, and the machines produce electricity. All of them are installed in clinics and hospitals. It's in full coordination with the Israeli army. The coordinates, the army knows the coordinates of where the systems are. And in the previous photo, in this photo here, when they integrated the first system, actually they openly mentioned this is a joint project between the NGO that we work in Gaza with and the Israeli Arava Institute for Environmental Studies. We managed also to send into Gaza an off-grid wastewater treatment system. Why off-grid technologies? Because you cannot rely on the network in the electricity network in Gaza. But these systems run 24/7 without being connected with the grid. And why wastewater in Gaza? Again, it's the lack of electricity. Wastewater treatment plants, all of Gaza is connected to the sewage network. Compared to the West Bank, they are in a very good situation, but they do not have electricity to treat the wastewater. So what happens to the wastewater? They dump it into the fields, okay? Pollutes the aquifer. The water that used for agriculture is polluted and comes back to Israel and the West Bank as strawberries and tomato. Or they dump it into the Eastern Mediterranean. 70%, yes, 70% of the beaches in Gaza are polluted. People cannot swim there. They do swim, but they should not. What happens to the pollution, to the sewage in the Eastern Mediterranean, the Gaza beaches? Doesn't stay there. The streams in the Eastern Mediterranean are south-north. The sewage goes to Ashkelon, and Ashkelon is a home for one of the largest desalination plants in the world. And if you have organic pollution, if you have sewage in the seawater, you cannot desalinate the seawater. One of the major challenges of desalination plants, what they call it's the biofouling. That means the microorganisms grow inside the membranes, and they grow because there is organic content, because there is sewage. And Ashkelon closes like every year, 2-3 times, because of the pollution that comes from Gaza. So such a technologies help the people in Gaza to use the recycled water, okay, to solve an environmental issue, but also the recycled water to be used by farmers, by women that they lease land and they grow animal feed, which is like very much needed inside Gaza Strip. These are photos. These are not tunnels. Okay, these are the foundations for the wastewater treatment plant off the grid, and all of these systems are functioning now. Okay, let's come to the West Bank. Probably like 15 kilometers from here, there's a city called Al-Bira near Ramallah. They have very nice wastewater treatment plant. high-tech, treats the wastewater of Al-Bira, parts of Ramallah, and some of the Jewish settlements in that area. I think Sagot, and the inlet of the sewage to the wastewater treatment plant is in Area B, which is under the Palestinian control. The outlet of the sewage plant, the wastewater treatment plant, is in Area C, which is Israeli control. Okay. Now the Palestinians treat the water, but they cannot use the recycled water. And this recycled water follow the, if you can see the mouse here. This is the treatment plant here. Feeds the water, flows into this valley. We live in mass. We call this Wadi Lane. Okay, high quality water, good for agriculture. The Palestinians cannot use it. The Israelis do not use it. And here, this is Kufra Aqab, Kalandia, northern parts of Jerusalem. They have raw sewage under the Israeli Jerusalem municipality. Okay, sewage comes from these areas, flows to the other valleys, and mixes here with the treated wastewater. here we're talking about 2.5 million cubes of water. So all efforts done upstream by the wastewater treatment plant, they go to they got lost. It continues to flow polluted to Wadi al-Kilt, which is a touristic historical site, natural springs. Mikorot, the Israeli water company, had to close 2 wells because of this pollution. This project is a priority for Israel because they want to prevent the pollution. It's a priority for the Palestinians because they want to use the water, and because the Israelis and the Palestinians don't talk to each other. This project is stuck since 1999. We have a Palestinian researcher at the Arava Institute said, I know this challenge, let's try to solve it. He worked with the Palestinian Water Authority. We worked as an Israeli organization with the civil administration in Israel. It took us 4 years to take this photo. Palestinian Water Authority with the civil administration, engineers, technicians, 4 years to convince them to come together. Once they came here, I took that photo. They used just engineering language and technicalities. And within 7 months, we were able to get a building permission for a pipeline that will take the treated wastewater from Al-Bila to the Jordan Valley, to Jericho, for the Palestinian farmers to be used for agriculture. And that solves the impact of the climate and the water scarcity in the Jordan Valley. We're talking here about like 2.5 million cubes of recycled water. And this is only one example. There are a lot of examples like that also in the northern parts of the West Bank, where sewage flows in Area C, goes to Israel. Sewage and industrial waste flows from Hebron, the Negev, Gaza to the Mediterranean. And because of the lack of trust and lack of communication between the two authorities, such projects are stuck for a very long time. Other projects that we conduct as an Israeli organization in the West Bank, this is an off-grid wastewater treatment technology that we developed at the Arava Institute. We have projects in the Negev, in the Bedouin communities, that helps people to recycle water and to generate water for agricultural activities. This project in a school in Asir al-Shamaliya, it's a village in northern Nablus, treats the wastewater for the school, and the treated wastewater is used by farmers to solve the challenge of water scarcity. And here you can see in the middle with that red t-shirt or brown t-shirt to Brian, who interned with the Arava Institute. And guys, this photo is taken. We have our Israeli team, Israeli Jewish team in Nablus, okay? And Clive, who's the head of our Transmountain Water Management Center, goes to Nablus probably every other week as an Israeli Jewish. And you know what's happening in Nablus every other week, right? And we, as an Israeli team, are welcomed in the northern parts of Nablus. The head of the municipality there hosts the team, and they openly say that it's cooperation between the Arava Institute and the municipality. Other projects in the Jordan Valley, off-grid desalination to help farmers cope with the impact of climate and scarcity of water. And this is a joint project between the Arava Institute and Oxford University on building a model for the natural resources in the region, Israel, Jordan, Palestine. How will the natural resources look like 2030, 2050 if each country plans alone, and how things will look like if the three countries plan the natural resources together. Another project that we have actually to cope with the impact of climate change, the droughts, the water scarcity, the increase in temperature, is the dual use of land, agri-photovoltaic. It's the use the land for agriculture and also for energy production. We have 3 pilots in the Arava, and we tested different types of crops, the impact of shading on the performance of the crops and the water evaporation, the impact of water evaporation and the electricity production in the farms. We managed to grow several crops, and we saw very minimum difference between the control and the experiments. Thank you so much.